Algebra 2, we're looking at lesson 5.8, and notice we're given a learning target to simplify. I can simplify or reduce square roots. I think it's so important to realize what we're not doing. Every once in a while, a student might wonder, well, don't I just type in on my calculator what the square root of 8 is and say I've got 2.8 or something like that? No, please understand that's not what's being asked. Clearly, 8 is not a perfect square. So what we need to do is break this radical down. And first off, I want to review the primes with you. Prime numbers are numbers that are only divisible by themselves and 1. 1 is not included. But the first prime would be 2. Another prime would be 3. 4 is not prime because you can divide it by 2. 5 is a prime number. 6 is not. 7 is. 8 is divisible by 2, so it is not. 9 is not. 10 is not. Any even number is not. 11 and so forth. Really you don't have to have a huge list of primes. Usually 2, 3, 5, and 7 are going to suffice. But what are we looking for? We're going to do a prime factorization. And guys, prime factorizations, you can make a prime factor tree. I really like doing something just a little bit different, making what's called a division tree. A division tree organizes everything in a little pathway so you don't lose factors. The prime trees, sometimes kids get frustrated. They'll say, oh my gosh, I forgot to write one down. The first prime number is a 2. We should see if 8 is divisible by 2. 8 divided by 2 is 4. And then we're going to say, well, check 2 again. Is 4 divisible by 2? Yes, 4 divided by 2 is a 2. And here is your little prime factorization. You have 3 2's all multiplied in a row. Some teachers call this the hockey stick method because when you make your trail of prime numbers, it kind of looks like you've got a little hockey stick here. But look, the 8 is really 2 times 2 times 2 times 2. There are 3 2's all in a row. And guys, a square root is really a second root. What you're going to do is you're always going to look for doubles. You're going to look for 2 of the same thing and circle any doubles that you have. Once you've circled a pair, bring one of them out and then cross out your circle. So I'm going to pull out one of these 2's. I'm losing that circle now. I still have a square root, a second root. I still have a 2 inside. And guys, that's my final answer. This is what it means to simplify or reduce a square root. So hopefully you're getting that. Let's take a look at the 54, the square root of 54. You might wonder if we can break that down. Always start with a 2, see if this number is divisible by 2. 54 divided by 2, well, either in your head or through a calculator, you can see it's going to be 27. And is 27 divisible by 2? Well, no, it's an odd number, so it's not. Instead, let's try a 3. And 27 divided by 3 is actually a 9. Try 3 again. Keep trying your primes until you can't work them any longer. 9 divided by 3 is a 3. And look at that. You have 2 times 3 times 3 times 3. If you're ever worried that you didn't get that prime factorization correct, please realize it only takes a moment to double check to say, well, I think it's 2 times 3 3's. You can see, sure enough, you got it. But look, we're going to very quickly jump back up here and try to look for doubles. And there are only a pair of 3's here. So what did we say we were going to do? pull one of those out, then kill that circle. Inside the radical, I have a 2 and a 3. They're next to each other, though. 2 times 3 would get you a 6. So we're going to be left with a 3 and then a radical 6. Let's look at 2a. As we look at 2a, it says simplify. Now, I hope you know that square roots and squaring are actually inverses of each other. Squaring a square root makes the square root go away. You're just going to be left with a 3. Now, by the way, if you're nervous about that, you could most definitely double check that that is true. You could say, look, I've got my square root of 3, and then I'm going to square it. Sure enough, I get a 3. So square a square root, it goes away. When you're looking at 2b, look at this. You've got two numbers inside. They're both prime numbers. I can't reduce either one. I can't break down the 2 or the 5, but I can multiply them on the inside. I can make this one radical, and 2 times 5 is going to get you a 10. Your final answer is just a radical 10. For 2c, there are 2 methods to help you out, and I do want to show you both. Method 1 kind of goes with what we just did a moment earlier. You could say, look, I got a radical and a radical. How about we just multiply those 2 together? 3 times 12 is 36. And sometimes, not always, sometimes you're going to have a nice, perfect square. You're going to see in ALEKS, that's not always going to happen. When it does, it's pretty nice to do the problem this way. You can say, hey, look at this. My numbers multiply to a perfect square. I just get a 6. But look, I guess what I want to tell you is a lot of times it's not going to work out quite so nice. The 12 is not prime, so I'm going to break it down. 12 divided by 2 is a 6. I can divide by 2 again. 6 divided by 2 is a 3. So this radical 12 right here, so if we were to look at that, that 12 is really, breaking it down, 2 times 2 times 3. Then what? We could join these 2 radicals together. We could say, hey, you know what? Let's just make them one radical. We've got a 2 and a 2. We've got a 3 and a 3. And do you see any doubles? Well, you do. You can see that you can take out a 2 and kill that circle. Take out a 3, kill that circle. There's nothing left. 2 times 3 is just going to get you a 6. Sometimes ALEKS will give you some problems where you will have a radical left and it will be remaining. Guys, number 3 probably looks to be perhaps the most frightening of all of these. My suggestion is take your 2 square roots and turn them into 1. 75 over 12, and you know, this is where you could reduce with a calculator or by hand. If I just gave you 75 over 12, and if we did alpha y equals, well, 75 over 12, reducing that, you could actually divide out of 3, guys. And that's 25 over 4. So you're really dealing with the square root of 25 over 4, which is really the square root of 25 over the square root of 4. Final answer would be a 5 over 2. So that can be done pretty quickly. Here is our last problem of the day. When you see something outside of parentheses, you might guess that we're going to distribute, and we are. The 5, however, is not inside of a radical. So when I multiply radical 2 times 5, I'll just have a 5 on the outside and then a radical 2. But radical 2 times radical 3, that's where you can multiply the two insides together. And guys, then you are done. So that is lesson 5.8. We're doubling up. It's a block day. So we've got homework 5.8. But we also want to look at practice test 5.7 and 5.8 as well. It's a nice long day. We can certainly do both of these.